Good evening, everyone. It's the privilege of ISSS to welcome Professor Ashok Jhunjhunwala. He is a professor of electrical engineering at Indian Institute of Technology, Madras, IIT Madras. He is a member of National Academy of Engineering, NAE, USA, and a fellow of IEEE and World Wireless Research Forum. He is also a fellow of the four S&T academies in India, namely ISNA, NAS, IAS, INAE. Professor Jhunjhunwala was conferred one of the highest civilian honor, Padma Shri, in India. It is indeed our privilege to have him here. He is considered a pioneer in nurturing industry academia interaction in India towards R&D, innovation and product development. He conceived and built India's first university-affiliated business park in IIT Madras, that is the IIT Madras Research Park. He has been developing products for masses, affordable yet technically advanced products in India, like wireless in loop, local loop, remote health monitoring system, ATM, solar, DC, homes, affordable electric vehicles, etc. It's our privilege to have you, sir. Thank you for accepting our invitation. Now the floor is yours.
All right. Thank you very much, ISSS. I had not heard about the organization till I got a mail, and I said I'll gladly do this if they are willing to hear me on what I can talk about more easily and what my current passion is. And thank you for inviting me. And I'm very glad that I see people like Professor Kulkarni there. I'm going to give a talk, and this is what I asked him, that is it okay if I give a talk? But a very different kind of topic. What does it take India to get all its electricity from renewable energy? I mean, today, renewable energy, solar is, of course, a renewable energy. Wind is considered renewable energy. There are few other things which are considered renewable energy, but I will say solar and wind primarily. And what I'm going to present is, what does it take if we can get all our energy from renewables? Today, most of our energy we get from coal. In fact, our renewable energy in energy terms is only about 8 or 9. All electricity in energy terms is only about 8% or so is from renewable energy. 92% is from other sources. So here is what I am going to talk about. And I'm going to get into technology, economics, and then a strategy. And I'm going to get a little bit deeper into economics. Sometimes we engineers don't get into the economics in depth. And this is very critical in trying to get something to proliferate in India. You must understand what it means in economic terms. And that's what I will do. So in a very rough way, if we start with, and please interrupt me as often as you want. It's a small group of people, so if it is more important that I try to convey something, and if you don't understand, stop me, maybe I'll try to convey that better. So today, solar energy is used to produce electricity, and today when it is produced in large farms, the cost comes out to be 2.50 rupees per kilowatt hour. Kilowatt hour is the per unit of energy used in India. So per unit it is 2.50 rupees. How am I putting this number? If you look at the bids, various government and other entities ask for that people build the solar parks, produce electricity and give it to us, offer it to us. What price will you give it to us for the next 20 years, 25 years? And the bid comes to 2.42 rupees, 2.57 paise. It varies around 2.50 rupees. Same thing is there for wind. There are large wind plants all over the country, significantly in Tamil Nadu, in Gujarat, but many other parts of the country. And again, if you look at what they offer the electricity to the various power utility companies is at approximately 2.50 rupees per kilowatt hour. Now, to a great surprise, you'll find that coal, if somebody sets up a coal plant, also it costs around 2.50 rupees. Now, the new coal plants will cost higher because there is now increasing regulation on the amount of pollution that you can create. So if you take all those into account, the new plants may cost more like 3.50 rupees or something like that. But there are older plants which are rupee 50. So on the average, around 2.50 rupees per kilowatt hour. Now this is very surprising that in India, all these three forms of electricity cost same. Now, of course, the exception is oil, gas-based, diesel-based plant. The cost is here between 12 rupees to 16 rupees, more closer to 16 rupees. And diesel may even cost 18 rupees or 20 rupees. We turn on diesel generators whenever there is no electricity, and that can cost around 20 rupees. Now, per unit. Now, how do you calculate per unit? You actually take the total cost, all the costs, and you find out the total energy produced. And then you divide that and say, this is the per unit cost. You take into account the capital cost, therefore you take into account what is called depreciation. You take into account the finance cost, the interest, everything is taken into account. This is where what a DISCOM power utilities can actually buy electricity, 2.50 rupee for solar, 2.50 rupee for wind, 2.50 rupee for coal, and if you want oil gas based plant, it is 16 rupees, sometimes 14, 12. 12 is not very common. And if you use a diesel generator, which, for example, IIT may be using it, we use it, costs around 20 rupees per unit. So what stops us from converting fully to renewables? Because the cost is very attractive. So first question is, do we have enough solar and wind? Suppose we want to replace all our coal-based and other forms of electricity with solar and wind. Does India have enough capacity? Now, I don't want to get into detail. There could be a separate talk on this. But India has enough solar and wind, both coastal and ocean wind, for today and tomorrow. In fact, I had done a calculation where we saw that about 5% of desert area of Rajasthan alone could give you all the electricity required today, 4 to 5% of desert area. So there is enough solar and wind capacity possible if we want to do. So the issue is not with whether we have enough. It is possible for us to do it. But then what is the problem? The problem is that solar and wind is not available 24/7. So this tariff is 2.50 rupees whenever sun is up and it is giving solar electricity, solar-based electricity. It is 2.50 rupees for wind whenever wind is there. It is not for 24/7. And sun is not there except for maybe 8, 10, 12 hours. Wind is there in certain months of the country, little more than others. And even there, maybe there for 6 hours, 8 hours, sometimes 12 hours. So it varies. Solar and wind is cannot be controlled by a human being. It cannot be increased, decreased, turned on, turned off. Whereas coal can be increased, decreased, turned on, turned off. That is coal, oil, gas plant, diesel generator can be turned on, turned off anytime you want. Solar and wind, I will say, will depend on the God. When God wishes it, it will be there. Sometime it will not be there. You can't predict for certain. You can have a reasonable prediction that it will be there most of the days in daytime. If you go to places like Rajasthan, there is hardly any rains, so those places it will be there for 12 hours for major part of the year, but yet it is unpredictable. So what do you need to do if you want solar and wind alone? Now, the other important point, which I think most of us who understands a little bit of electricity that knows that electricity, when once produced, must be used immediately. At every instant. It has to be, whatever you generate and whatever you consume has to match at every instant. If power produced is less than demand, which used to be common in the yesteryear, there used to be load shedding. For example, 12, 13 years, 15 years back, we had a huge shortage and there used to be load shedding. But from around 2005, new power plants kept on coming, mostly coal power plant. It kept on increasing. By 2014 or 15, we had surplus coal-based plants. So that part we have taken. But load shedding is one way of matching. If your power is produces more than demand. If demand is less than the power produced, if power produced is less than demand, you can do power cutting. But if what if happened if demand is less than the power produced? Power produced is surplus. Well, you have to reduce power production. There is no other way out. Maybe you can dump it, some excess power, but even dumping is not so easy. You have to burn the power. But otherwise, you reduce the power production. And you can do that instantly in oil or gas plant. You can reduce. In coal-based plant, you can't do instant reduction, but you can reduce it in an hour or so. So basically, the conventional fossil fuel-based plants enabled us to do the control. Alternatively, what one can do is try to play with the demand and what is called demand management, sometimes also called a part of smart grids. You increase, decrease, postpone use of power to match generation. You get a signal saying that now power availability is at low cost. You increase your power usage. Or it says no, right now power is a shortage. You can decrease the power usage. You can sometimes postpone the power. You have a washing machine, you turn it off and turn it on when power available is surplus. Now these are all part of demand management, and smart grids, which you may be dealing with, had a lot to do. It came up in last 15 years. It went off to a certain extent, but beyond a certain point, smart grid do not work. So very often tariffs are used to get distributed customers to manage this. So if you are given lower cost power, I'll tend to use it at that time. And encourage when excess power is there, discourage when power shortage is there. So this is an area which came up tremendously post 2000 and has kind of the real thrust of it has kind of come down, because you could only do so much. You can only do so much. You can incentivize or disincentivize only so much. So it is no longer a hot topic as I'm concerned, as far as I'm concerned. Of course, there is still a lot of work goes on, but alternatively, can you store electricity? Now, electricity cannot be stored as itself. Well, in capacitor bank you can store, but you require a huge capacitor bank and you can store very small amount of energy. But otherwise, you convert it to some other form and store. And reconvert to electricity when needed. So when you have surplus power, you convert it to some other form, store it. When you need more, you reconvert it back to electricity and use it. Now remember, there is going to be losses in both directions. Conversion from electricity to whatever form, and then from whatever form to electricity. So you have to take into account the losses all the time. For example, one common way of storing electricity, you have a kind of a tidal power plant. You have the water at the top. It is kind of stored. You use it to get the power. When you have excess power, you pump the water back from the tank below to up, and store it, and then convert it back when you need. This is about 30 to 35% losses, because you are pumping water from a lower area to upper area, and then again using the water flow from upper to the lower area to generate electricity. About 30 to 35% losses. It can only be possible if there is a real height difference and there is a storage at the top and storage at the bottom. This is used at times, but not very efficient. 30-35% losses, and only in some places. There have been all kinds of other storage. For example, there has been one storage is called flywheels. You start using flywheels and get them to turn faster and faster and store the energy. The problem is that these flywheels will gradually face all kind of resistance and slow down and to that extent, the storage will only last for a certain small amount of time. Of course, you can try to make a vacuum flywheels, they will last longer, but even then there will be mechanical losses, friction losses. Lasting for very long time is not possible. Short time, you can actually do this. Expensive. There has been talk about converting into hydrogen and converting hydrogen back to electricity. This has been going on, a very hot topic. Lots of people working on it. But if you really look at the cost today, it's very, very high. Losses are somewhat reasonable, but still high. The most common way is convert it to chemical batteries. And we have all used it for long. You store the excess electricity into batteries and take it out from the batteries whenever you need it. And then there are a whole different kind of batteries, lead acid batteries, lithium ion batteries, and then there are future batteries like various solid state batteries and others. This chemical batteries, particularly lithium ion batteries, is becoming very, very dominant, and this talk will largely talk about lithium ion batteries to become the storage and how can this be possible, at what cost this will be possible, etc., etc. So there are a whole range of batteries, but frankly speaking, if you work out the full cost of economics, you will find lithium ion comes somewhat closer, and still we will see not as good as we really are looking for. So what are we talking about? So if you want 24/7 renewable, you take the AC grid, whatever is available. Let's say we are generating most of the power using renewable. And then we convert it to DC, because all batteries are DC. You convert to DC, store it. This can be done on demand. You can convert more electricity or less electricity. You can control it. And whenever you need, you take the electricity back from storage, convert it back to AC. This is a bidirectional converter plus storage. This can be connected to grid wherever you want, in your offices, in your homes, in large complexes, on the grid, and that can be the storage of electricity, which will make renewable energy available on demand. So this is the critical part. Renewable energy without storage have to be used instant they are produced. Okay. So if I start talking about grid energy storage or large storages, there are generally two types of storage, and I want to point out because very often there is a confusion. What is a short-term storage? Short-term storage is that for a few minutes there is a certain increase, then a few minutes there is a certain decrease. So it lasts for a very short time. So it's not a very long term, and it's a small amount. For a few minutes you store a small amount and then you take it out in the next 10 minutes or so for a short time. So it kind of fluctuating demand or fluctuating generation, it matches. So this is used to some extent. These batteries has to be suddenly large amount of electricity going in, suddenly large amount of electricity coming out. It's a fast charging rate, and you need to do it very, very often. So it's a different kind of, this is really different kind of storage, more trying to take care of immediate variation on the demand supply. I'm not going to talk further about it because this is not the real storage that we are talking about. The other is energy storage, where you take hundreds of megawatts hour or tens of megawatt hour, store it because you have suddenly produced from solar or from wind when it was getting generated, and use it later in the day, maybe 8 hours, 12 hours. Use solar energy in the evenings or in the night. Wind energy, store it wherever it is available, and it will produce pretty much almost every day, small or larger amount. Store it and then use it whenever you need. So this is what I'm going to talk about, energy storage for enhancing renewables. Let's get into the depth of that. Now, a question that I will ask is, how much does this storage cost? Now, these are batteries. So you have to buy batteries, and buying battery is capital cost. So I'll buy a 100 kilowatt hour battery or a megawatt hour battery or 1 kilowatt hour battery that our home backups use. How do I From there, that I'm buying one time, I may use it for 3 years, 5 years, maybe 10 years. How do I take into account the cost of storage per kilowatt hour? I will have to use, normally for any capital cost, the way to make it into a variable cost is depreciation. Calculate the depreciation and interest rate. Now, all engineers should know what depreciation and interest rates is. Interest rate, at least we have some feel. Depreciation is that you say the battery is going to last for 4 years. So today you have bought a battery of, let's say, 1 million rupees, and maybe you'll pay 250,000 rupees per year for 4 years. That's a depreciation, 250,000 rupees. Or you may say, no, first year you may pay slightly less, then you may pay slightly higher. So there are different methods of depreciation. That depreciation will tell you, okay, this is the cost per year. Similarly, interest you can calculate. You have taken a bank loan, and for doing this, of course, whenever the depreciation can be used to pay back the bank loan, but whatever is balance on which you take the interest, you calculate the interest for the year, and that's a cost per year. So that is the way depreciation and interest rate has to be, capital cost has to be converted into depreciation and interest rate. How much does the storage cost also depends on how many times can it be used. So normally you can't say that this battery will last for 4 years. That does not make sense. One often says the battery will last for 1,000 times you can charge it and discharge it, or 1,100 times you can charge it and discharge it. So number of charge-discharge cycles, and depending on the batteries, it may have a 300 charge-discharge cycle, or there may be 3,000 charge-discharge cycle. So you need to calculate how many times you can use it. Then what is the cost per usage per cycle? Of course, there is electricity that you are filling and taking it out. That will leave it out. But is there any other cost in operation? Are there losses? Is part of the electricity gets lost? Then that cost has to be added. When you take out, if you put in 1 kilowatt hour, suppose you bill and take a unit 1 kilowatt hour from the electricity grid. When you take it out, is it 1 kilowatt hour or 950 watt hour? In which case 50 watt hour will be the operation cost. There may also be other operation cost in terms of some maintenance cost and some other people you may have to put depending on what kind of storage you use. The other important cost you have to all the time worry, how long can you store without decay? You have stored it and you think now you have a megawatt hour of energy stored. So you have it. Will it remain a megawatt hour 10 days down the line? Now you may use it after 4 hours. Will it remain exactly a megawatt hour? How much is the leakage? Normally, very small leakage for a day or so. But if you keep it for longer time, there can be leakage. We have to take that into account. Based on that, you now have to learn to compute effective cost per kilowatt hour of usage. Because finally, I want to understand how much, when I store and use it, I'm producing at 2.50 rupee, and then I'm storing it and then using it. How much does it cost? So per kilowatt hour of usage cost is what we have to determine. There are other costs, environmental impact. If the battery is going to last for so many years, what will happen? In the making it, have we damaged the environment? In disposing it off, are we going to damage the environment? Is there toxicity? There are hazards? Is there a recyclability? All these are important costs, generally not taken into account. But the trend is, no, if you are talking about renewable energy, you take all this into account and make sure that it is fully recyclable. So that today, the focus is on fully recyclable batteries. Lead acid batteries are toxic. It's not fully recyclable. So all those things you'll have to take into account. Even in lithium-ion batteries, certain batteries are recyclable, certain batteries are not recyclable. So you have to take that into account. But all these parameters need to be taken into account. So as I point out, today renewable in India, and this is the India cost with all its India's finance rate and everything. Renewable energy cost in India is about 2.50 rupee per kilowatt hour. So with storage added to it, when renewable is not available, total cost per kilowatt hour must add 2.50 rupee plus a certain amount. What is that plus amount? Now, This plus that amount will also depend on how many times will you charge discharge per day. Now, why do you will ask me today also, somebody morning asked me, why does it matter? Suppose I have a battery which lasts for 1,000 cycles. If I charge discharge once a day, it will last for 3 years roughly. But if I charge discharge twice a day, it will last only for 1.5 years. Now, the capital cost may be the same. Interest cost is not same. For 1.5 years, interest cost will be less. 3 years, interest cost will be more. So my effective cost will go down. So I need to calculate how many cycles of battery charge discharge per day. So this becomes another parameter. So there are a large number of parameters. So renewable energy uses, let's assume that 70% of electricity is used immediately. Renewable energy. Solar is produced, it is used immediately. That's what we are doing at IIT. For example, solar is produced and then we are immediately using. But let's assume 30% is kept for later use when renewable is not available. Let's say 30% is used to be used in the evening. Now I've taken the 70 and 30 as some arbitrary number. I'll justify that and also tell you what happens when it is 50-50 or something else. And let us say when I take 30%, and if for this 30% I store it. So let S be the cost to store 1 kilowatt hour in storage and then retrieve it later. So for this 30%, my generation cost is 2.50 rupee plus S is the storage cost. So for 30%, my cost is 2.50 rupee plus S. For 70%, my cost is 2.50 rupee per kilowatt hour. So what is my average cost? For 70%, 2.50 rupee, 30%, 2.50 rupee plus S, and this comes to 2.50 rupee plus 0.3 times S. Now remember that 0.3 comes because I have taken 70% immediate use, 30% through batteries. If I make it 50-50, it will become 2.50 rupee plus 0.5 times S. It's a very simple thing, but one must keep that in mind and will use the computation. Now let's take the battery. As I told you, what is the cost of usage per kilowatt hour? Depends on type of battery, effective life cycle, capital cost, number of cycles used per day, end-to-end energy efficiency. Am I able to put in and take out as much? Now, typically in a lithium-ion battery that I'm going to talk about, end-to-end efficiency can be 96%. From AC, I convert to DC, store it, take it out, convert it back to AC. For large storage, I can try to do 96%. 96% is tough, but I can do 96%. There are people who say in coming years, I will be able to do 97, 98, but 96% is doable. Then I have to take into account the interest rate. Here I'm taking the interest rate to be 2% to 10%, but actually interest rate can even be higher. I'll talk about this as we go forward. Let us take 4 different types of batteries. And these are the 4 types of batteries which are available today. And I'm not talking about tomorrow's battery. And I took 4 types of cells where cell cost is, with cell A, the battery cost will come to 15,000 rupees per kilowatt hour. With cell B, it will be 20,000, cell C, 25,000, cell D is 30,000 rupees. Now, these are, of course, large battery, 100 kilowatt hour or a megawatt hour. This is the cost per kilowatt hour. And I put rough cycles. Actually, this was more like 4,000. This was more like 8,000. I made it 3,650. It is 365 into 10 to make it a little bit more easier computation. But and the chemistry for this battery is NMC. If you change it to 4,000, it won't make much of a difference. Just it will make minor difference. This is advanced NMC. This is LTO. This is LTO. I take 4 kinds of cells which are available today, which I can purchase, and I am at IIT Madras able to build this battery. If I build a megawatt hour battery, I will be able to do it at this cost per kilowatt hour. This is what is doable today, and we have learned. We at IIT Madras have learned to build this battery. There are a few others who have learned to build batteries like this. Cells we are getting from elsewhere. Now, this is my first result. What is the cost per kilowatt hour? I'm taking into account the depreciation. I'm taking into account the interest cost. I'm taking into account some operation cost, the number of times it is used per day. So let's assume that I'll use 1 cycle per day. So 1 cycle per day, and if I use this cell A, 3,650, means it will last me for 10 years. This will last me for 20 years. This will last me for even longer. So of course, things don't last beyond 10, 15 years, but I've done a computation. Let's look at the cost. The cost of depreciation and interest cost I take into account, and I therefore cost effective cost per kilowatt hour. Now this is plotted as a function of interest rate. Now if I take 10% in interest, and in India the interest rate will be above 10%, 10, 12, 14. I have not even extended this, but even at 10% interest rate, if I look at it, depending on the battery, my cost per kilowatt hour is between 650 to 9 rupees at 10%. But look at the other end. At 2% interest rate, it is only 3 to 5 rupees. And for these batteries, it is only about 3 rupees. The first important thing that I am trying to tell you, that any capital cost that you do, and you use it for long time, 10 years, 15 years, the interest cost dominates everything. In fact, cost more than doubles because of interest cost. Sometimes it becomes almost 3 times because of the interest cost. I want to point that out because we work very closely with United States, Europe, where the interest cost is between 2-3%. And we very often listen to them, get their numbers, and just start using it blindly in India. It doesn't work in India. In India, the interest rate, you try borrowing money at 12%, it'll be tough. Since the long term, I'm saying let's assume some 10%. And even then, you get totally different picture. And just remember, 2 rupee 50 paise was my generation cost from renewable. Now I add 9 rupees. So if I put it into a battery and take it out, it is 11 rupee 50 paise. Even if I take the cell B and I add 650, it is still 9 rupees. So you just imagine the storage cost is so bad. And this storage cost is today after we have done a lot of work and brought down the battery cost. 4 years back, 5 years, when I started, this numbers I had done the calculation, it used to be 18 rupees per kilowatt hour. And remember the cost of diesel generator was 18 rupees, it was roughly the same. So I said, well, there is no point in doing all this. But over time, we have worked and brought it down to close to 7 rupees, 6 rupees 50 paise, the best battery. But still, my electricity cost was for a toss, was very high. Well, wait for a minute. I had one time thought that, well, it is so high that we can still not. I got the feel of 7 rupees last year. But I still thought 7 rupees additional cost beyond 250 just too high. My one weekend last year, about a year back, I was visiting Indian Institute of Science, Bangalore. My son is a faculty there, and I was on the weekend sitting at his home and relaxing. And my son, my daughter-in-law, and my wife went for some shopping, and I was just decided to stay at home, relax. And while I was relaxing, I sort of, in my mind was going around 7 rupees, 950, it is too high. And then that's the time I had done this calculation. This was done in Bangalore. And then I started thinking more and said, well, should it deter me? And I came to the conclusion, no, it should not deter me. And I'll show you. If instead of 1 cycle per day, if I use 1.5 cycles per day, my situation improves. In West, in Europe, etc., cost will go down below 3. In India, cost will go down a bit, but still it is 5 rupees 50 paise. Of course, if I do 2 cycles per day, my cost comes down further to 450. That will vary. But can I do 2 cycles? Sun is there in the morning. Wind, we don't exactly know. Maybe evening. Maybe we can do 1.5 cycles a day. 2 cycles will be tough. But maybe we can do 2 cycles. That will be very good if we can do that. But 1.5. Of course, if I went to and could do 3 cycles per day, then my cost will come below 4 rupees. And if you look at it, the curve flattens. The interest rate doesn't matter as much. Why? Because if I use 3 times a day, my number of years that I use becomes less. I don't use it for 10 years. I use it for 3 years. But so I will take into account that I can safely use 1.5 times a day. I still have to work with 5 rupees, 550 and all that. Well, this is the raw cost of storage. Let me now redo the computation. So here I saw cell B, which is about 6,000-7,000 cycles, works out to the best, and the cost comes around 650. I don't want to elaborate on that. Out of the 4 cells, that is the best. In Europe, only the LTO cells work. By the way, that's another problem. Very often, our policymakers, so influenced by the West, will say, oh, let's use LTO cell. Well, LTO cell does not work in India. LTO cell, if you look at that, see these numbers. LTO cells diverge out. It's lowest here, but it's not lowest here. And as the interest rate goes up, it will go even higher. But very often India does not even try to do this simple computation. That doesn't matter. Point is, we can find 5,000-6,000 cells and we can actually pay it. Of course, in West, at 2% interest, LTO makes much more sense. They keep on beating the drum to ₹50, and we are so influenced by the West, we also start repeating that. Our scholars have seen papers coming from India, assuming, without understanding, assuming this and repeating what was been done in the West, which I think your society should really understand the implication of interest rate, and therefore everything, the complete economics and technology changes. You will not choose LTO cell, you will use NMC cells with about 5,000-6,000 cycles. But let me now come back to a very interesting thing. Remember, 70% of energy was directly used. So there my cost was only ₹2.50. 30% only was going through the storage. So only for the 30% I have to add that 6 rupees or 7 rupees. So my cost per unit, average cost per unit is ₹2.50 plus 0.3 times S. So if S is even 6 rupees, 0.3 times X is only 2 rupees. So I can get electricity at ₹4.50 with storage. Assuming 70% I directly use, 30% I use it later in the day. Now one may say, well, but maybe in the evenings and nights you may, well, of course, evenings and nights wind may also be there. Maybe you have to can't use it instantaneously. Maybe you can do 50-50. Well, sure, we can do 50-50. The cost will go slightly up. But let us begin. Let us start. Today with 30%. Our cost is around 4 rupees. By the time we really build this and store it and make the whole thing work, it will be 3 years. And in 3 years, the cost of batteries will further come down. The cost of battery is falling rapidly. Whatever numbers I have told, at least 20-25% will come down. That time we can do 15%. By the time we start deploying it, we can go to 50%. And in that case, even 50% renewable energy will be at around 4 rupees. Now that is very powerful. Because what do we do? Most of us pay 5 rupees, 6 rupees, 7 rupees, 8 rupees, 9 rupees for electricity. And I can get renewable energy with storage at 4 to 5 rupees. I'm just to make that possible. So I'm saying makes sense to go up to 30% renewable storage today and keeps on, as the cost drops down to a battery more, keep on increasing to 40-50%. Takes years to build storage. So grid storage is becoming viable. But today we just import the storage. And when we import the storage, today also I saw, it's double the cost. And you're doing wrong batteries like LTO. This will never really solve our problem. We have to wait till the West does this all over and brings down the cost, and then we will start doing it. But what I am talking about, today we can build, and we are building it, and there is no reason other institutes also cannot help build it. We need to have a lot of entrepreneurs who can actually do this. We can run this. We can teach people how to do this and get Indian industry to take off. This is where I agree with Prime Minister on Atmanirbhar, but I don't like this empty slogan of Atmanirbhar without backed by solid science and technology and a program to really achieve this. For too long, we have had politicians just giving us slogans. We can today do this if we do hard work. But almost all policies are against it. In fact, policies will prefer LTO. Policies will prefer import. What are we talking about Atmanirbhar in this kind of situation? So the question is, I think making this storage, we at IIT Madras have done enough work that in a year's time, we will build this storage. Of course, we'll build a small 1 megawatt hour, half a megawatt hour. Then if you want to really build even 100 megawatt hour, 200 megawatt hour, it'll take a year or two. And then we build gigawatt hour and things like that. That's what will be required. Where can we begin? Can we begin somewhere? And my point was trying to go to the electricity board or Ministry of Power takes you only so far. Nobody understands, and they are so influenced by West who doesn't even understand the difference of interest rate, doesn't know how to build things at low cost. These are very low cost structures that we have built. Where do we begin? Another idea came to me. See, I am showing a picture here of our research park, but this is a kind of a commercial building. There are a large number of commercial buildings in the country. You know, there are close to 40,000 commercial buildings in the country. And for this commercial building, for example, at Research Park, I paid 9 rupees per unit. Commercial electricity cost 9 rupees per unit, including demand charges and everything. Of course, I use diesel generator at 18 rupees. This is what I am paying for this. Every large office complex pays for this. Institutes get concessional electricity. So don't take institutes. But any large office complex, any large commercial complex, and there are some 40,000 complexes and increasing very rapidly, they are paying 9 rupees and 18 rupees. Can I start by making a difference there? For example, can I use rooftops electricity? I'm doing that in solar, but you only can do 10 to 15% on rooftop. There's not enough space. So that cost very little, cost only 4 rupees per unit. Now, of course, if I did 100 megawatt hour, then I would have done 2 rupee 50 paise. But on the rooftop, you can do only 4 rupees per unit. There are independent power producers who actually produce electricity, large electricity, 100 megawatt hour or 300 megawatt hour, and we can co-produce with them. And they will deliver us guaranteed electricity. They mix solar and wind along with coal at 7 rupees. But then that's also I'm not interested, because that is again solar, wind, coal guarantee. Suppose I tell them, don't give me guarantee. Give me, I will help me. So suppose 20 buildings get together and say each of us want to do 5 megawatt hour somewhere, 100 megawatt hour. Each of us will have a share, and we will wheel it to our buildings. The wheeling cost is about a rupee, plus the discom will charge me something extra, demand charges, etc., etc. I can get electricity, solar electricity and wind electricity as and when produced, not guaranteed, whenever it is produced at 5 rupees per unit. This is a tough job, but it is possible. We are now trying to do this at IIT Madras Research Park. If I can get that, it requires a little bit of working, because generally power utility companies or discoms are not very much in favor. They want to sell their electricity at 9 rupees. But if I produce solar and wind somewhere and wheel it, I can get it at 5 rupees per unit. And at 5 rupees per unit, I add this 2 rupees extra, and my cost will be under 8 rupees, so more like 7 rupees. Storage usage cost, and all this will come to 8 rupees, or even less, 7 rupees, 750. To begin with, the first few maybe little extra cost, so maybe 8 rupees. So in addition, I can also use in research part we are doing, half the energy is used for air conditioning. So I can chill the water whenever extra solar and wind is available, store it, and then use it when I need. That also costs less. So all this combination can be done. And as I sort of said, as computed earlier, if 70% is used directly, 30% through storage. The storage add about 2 rupee 40. It can add less. 2 rupee 40 is slightly extra that I've taken. I've shown here less than 2 rupees. But with captive power generation billing at 5 rupees, I can still get at 7 rupee 40 paise. And I have 30 to 40,000 commercial complex. Less than what the commercial complex pays today. As cost of storage declines, I can use 50% from solar and wind directly and 50% through storage. First objective, eliminate diesel generator. That is costing me 18 rupees. If I have storage, I don't need to use that. Second, if time of metering is used, which is not there today, one can considerably gain. Storage cost can pay off in a few years' time. But even if you don't do that, it is viable today. I want to end by sort of saying that not only it is possible, it requires determination, it requires political will, it requires a lot of technology to be developed in India, it requires businessmen to see business potential and do it. India has plenty of renewable energy, solar and wind. Solar farms can set up in Rajasthan deserts and there is no rain there, 12 hours a day. We can add wind farms in coast and even in the ocean. Build storage initially in this commercial complex, maybe 1 megawatt hour, 2 megawatt hour, 4 megawatt hour. Over time, we start doing 50 megawatt hour, 100 megawatt hour. Initially start with 30% of energy through renewable, move it to 50%, and all this is possible by R&D, engineering, finance capital in India, if the right policies are there. And I'm very determined to do this. I plan to do this, irrespective of whether I get support or not. Thank you. So I'm stopping my presentation. I hope you were able to listen to it, and I'm going to take questions, answers, etc. I'm stopping my presentation.
Thank you, Professor Jhunjhunwala, for a great thought-provoking talk. I think people can post their questions in the chat window.
Or they can ask me. It's better as a small group. They can just one by one start speaking, turn their mic on, and ask me. I'll rather like to see them asking questions and then answer. I hope I have not gone too far off. Yeah.
No, you're right on time. Yeah. Right. Maybe I can start asking a question. Yeah. So what about, I think, the safety? Is that a problem of storing batteries in the commercial buildings?
Oh, this is a lithium-ion battery. Today you have enough batteries. Everybody uses UPS. It is not more unsafe than that. I mean, some care has to be done, of course. Fire can be there anywhere. I mean, but today you use fuel tank in the diesel generator. That fuel tank is very risky. You take care of them. There is always safety risk because if you are storing energy, but you need to take care of them. It is not something here and there we have to learn to use it in large scale. But today you are using it, and more we are using. We started to use electric cars. I think it's basically the point that I'll make is basically fairly safe. We have to make it safe. Of course, remember in early days, those of you have heard about how the petrol used to be very unsafe. Today, petrol is safe. They made it safe. That's where the engineering comes in. Same thing with the battery. Battery is a storage of electricity, so we have to do this. Okay.
The other question is, you showed in one of the graphs that the interest rate doesn't matter when the number of cycles is more. So what you are saying applies to any country, right?
Sorry. I think you heard the reverse. If you used more number of cycles per day,
yes.
Suppose you use 3 cycles per day, and suppose that battery lasts for 3,000 cycles. You are using 1,000 cycles a year, 3 cycles a day. So it lasts only 3 years.
Mhm.
So interest rate does not build up in 3 years.
Yes. Yeah.
Even if it's a 3,000, not 3,000, if it is a 6,000, 3,000 cycles, it would have lasted for 10 years, but now it will last for 3 years. If it is a 6,000 cycle, still it will last for 5-6 years. It would make a small difference. So slope was there, but not as substantial.
Not as much.
Anything that lasts for 10 years, 20 years will build up like anything. Interest rates build up.
Right.
It is one to the interest rate is power of 1 plus the interest rate. So if there is a 12% interest rate, it is 1.12 to the power of number of years. So even n is 3, 4, it is not that much. It is, but if n is 10, just look at what it means.
Right. Thank you.
So can I ask a question, sir?
Yes, Dr. Natarajan.
Yes, sir. Sir, I know you for last, say, 40 and odd years.
Yeah, and I saw your pictures and it disappeared.
No, I was trying to connect. I think it got connected back. So I was in BEL and then I started working solar way back in 78.
Very good.
Of course, we made actually 5 megawatt plant and later on scale up to 100 megawatt. But my real implementation came when I was in Ramaya Institute of Technology in Bangalore. I set up a 500 kilowatt plant.
Yeah, solar plants are now very easy to set up.
So
people are doing it all over the country.
Yes.
There is rooftop solar. There are big solar plant. That solar plant and wind plant is a commodity item. I did not talk about solar and wind plants. I talked about storage.
Yes, sir. See, one of the things what I was trying to promote the solar is like when it is more than 10 kilowatt power required for a say application, definitely I think the solar is a direct use. But when it comes to like anywhere between 1 to say 5 kilowatt, storage definitely helps to go in for a
no, I am talking about a 100 megawatt solar and storage.
Okay.
I am talking about 100 megawatt wind and storage. I am not talking about small storage. This is large storage so that you don't need electricity at all from coal. You can get rid of grid electricity.
But is there any plant like as you said like this?
There are a few plants right now coming up in the world. In India also we are trying to do a few.
Okay.
So just a very new area have come up in last 2 years. Last 2 years.
Yes, I only just want to know about the battery technology which like required.
I talked about that. I talked about NMC lithium-ion batteries. Talked about it. Okay.
But India is not producing, sir.
I think we can take 1-to-1 beyond this, Dr. Natarajan. We can get somebody else to ask questions.
Sir, can I ask you a question, sir?
Please, sir.
Myself, Ganeshan from IIT Madras. Sir, you are talking about this lithium-ion batteries. If we look at very huge storage capacities, do we have enough resources to produce?
Yes, we have enough resources. It would have been a separate talk. I can actually do this. We today are recycling lithium-ion batteries. It requires lithium, manganese, cobalt, nickel, and graphite. We can recover 90% of these materials from used batteries and use it to reproduce. This has given us that there is really no shortage. If we don't recycle, we'll be in trouble. The question that you are asking, you are from IIT Madras, write to me, sometime meet me. We are just setting up a recycling plant.
Nice, sir. Very nice.
Professor, my name is Ramchandra. Am I audible?
Yeah, Ramchandra, I don't see your picture, but Ramchandra Krishnaswamy, yes, go ahead.
Professor, the small capacity storage would mean the energy is consumed in the local area. But if you're talking about gigawatts storage, you need to have transmission lines very, very long distances and networking. Now, have you therefore factored the transmission losses in these cost estimates?
So I have so there are two things. Grid storage will be at the site of solar plant and wind plant. So anyway, the transmission losses are there beyond that. So solar, let's say, is produced in somewhere, let's say Rajasthan, and it is coming to Bangalore. Or let's say it is produced in somewhere outside Bangalore, about 100 kilometers. And then it is brought to Bangalore. It is anyway, the losses will be there. Storage, grid storage will be kept next to the plant. I had proposed alternatively that instead of storing it at the generation point, you do it at the distribution point. So if I have an office complex, that's a place I'm getting that solar power. Anyway, the losses are anyway there. That has to be already taken into account. Now I store it and use it. I'm trying to make only 24/7. So that extra 1 rupee that I put, 2.50 rupee plus 1 rupee, that was for transmission loss and transmission costs.
Very well.
I've taken that into account.
Very well. Thank you.
Do you understand that, Ramchandra?
Yes, Professor, I understand. Thank you. Thank you very much.
Okay.
Yes, good evening, sir. So,
Yes, Michael, slightly louder.
Yes, okay, sir. Yes, sir. I'm Michael. So I want to know. I just want to had like a question. For example, I want to know integration of like solar cells into like tile panels and glass panels. Would that help in reducing like the installation costs?
Yeah, you're again going back to the solar and wind. Solar and wind generation is now a well-beaten topic. It has been going on now, mature technology, 5-10 years. There are a whole lot of different experiments. Can I make solar cells with higher energy efficiency, higher efficiency? Can I integrate it with the tile? Can I put it at an angle, or should I put it flat? That's a totally different area. All these areas will give you incremental gains. But even without gains, cost is today 2.50 rupee per kilowatt hour. So I didn't talk about solar cells and how they should be installed. It costs us 2.50 rupee. If you do a little more, maybe it can go down to 2.30, 2.20, I don't know. But I don't think it is going to rapidly fall. I talked about something else. Solar is not available in the evening. So storage is needed. Solar power, I've assumed it will cost around 2.50 rupee. If it reduces to 2.30 tomorrow, 2.30 rupee, good. That will help us a little bit more, but marginal help. The storage is more important. If you did blind storage the way we do it in our, for example, at homes in UPS, the cost is 16 rupees per kilowatt hour. We are talking about reducing that cost. Effective cost, I'm talking about 2 rupees per kilowatt hour.
So thank you. I got
My talk was on that. If any one of you want my slides, write a mail to me. I'm giving you my, in the chat box, I'm giving you my email address. You need to write to me and I will send you PDF copy of my slides. So I've given in the chat box. Okay. Anything else?
Hello, sir.
Yes.
Pramila Manohar here.
Yeah, Pramila.
This SMES, superconducting magnetic energy storage, can this be any usage here?
Yeah, so I heard about this. I did a very small reading about it. There are lots of different storage that is coming up. In fact, I could have given you a talk about different storage technologies that are coming up. And all are either some distance away, years away, or at a very high cost. What I talked about is the sweet spot, where is the lowest cost available today. So, for example, solid state batteries will be the next batteries, from lithium-ion battery to solid state. Very likely, but it will take, to be able to match the cost of today's lithium-ion battery, it will take at least 6-7 years. We'll switch to those. Tomorrow, the various other batteries that you're talking about, superconducting, this, that, magnetic resonance. All these things are probably even longer, 10 years, 15 years. I'll keep working on them because you never know when it happens. See, even lithium-ion batteries did not exist. Suddenly it exists in a very big way. So we have to keep working on new technology and keep on making economic sense. But scaling and large-scale usage can only be done when it is a mature technology at the right cost point. Lithium-ion today, lead acid used to be used yesterday. They were mature. The price point was high, double this cost, but effective cost. But it was useful, so we used it. Today, lithium-ion is being used increasingly. Our laptop uses it. Our cell phones uses it. All the electric vehicles uses it. Now I'm proposing grid storage to start using it. Okay? Thank you.
Yes.
Somebody is, yeah. Any other question?
Prof. Jhunjhunwala, can I ask another question?
Sure.
Yeah. Your argument was
going on. Your
sorry, there is some repair work going on upstairs, so maybe I'll wait until that is over and then ask later. Yeah. Okay. Sure. Yeah. Your focus was on India, but I guess if you look at the world scenario, which countries are doing what you are suggesting? That is storage.
United States, Europe are already. Europe is doing a lot of it. United States is doing a lot. They have an advantage. Their interest rates are only 2%, 3%. So their costs, they have a much more cost advantage. They have started doing it at a large scale. The others will follow. I'm sure China will beat them in no time. Because China actually makes more cells than anybody else. Though I have not heard of major projects in China yet. But I have heard of California being a place where a lot of such things are coming up. Multiple places in Europe it is coming up. You know, they don't mind cost being slightly higher also. Their affordability is higher. In India, you have to all the time worry about costs. Okay?
Yeah, thank you.
Any other question? Anyone? Chandrashri Das, Aishwarya, Ganeshan, Rohit, Bhumika, Veda Sandeep, Anurekha Sharma. Any question?
No, sir. Thanks for an interesting talk. We are just assimilating what you have said, and maybe when we read further, we'll have further queries, so we'll write to you.
Sure. You can also, I've given my email, ashok@net.res.in is there in the chat. If anybody wants anything, they can get my talk, copy of my talk or anything else. Anyway, you have the recording, you can share it wherever you want.
Yeah. Thank you so much.
Yeah.
So Anant, are we ready to wind up?
Yes. Yeah. I think thank you very much for giving an excellent talk and what makes us think, and we hope that it will be heard by others, as you said, in the country. Even otherwise, you said you are determined to do it, and we wish this initiative great success. Yeah.
Thank you
Veda,
very
you
much.
want to close it? Thank you.
Yeah. Keep me informed about, but I'm very happy about what you told me about ISSS.
Yeah. Thank you, Professor.
Thank you. Thank you. I'm disconnecting.
Yes. Thank you very much. Yeah.
Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. I now see Harsh's picture. Okay, thank you.